Good. That's a good
Go,
sign.
and Lawton, I'm going to let you take it from here. Feel free to run through things, and I'll be back in a couple minutes just to check in.
Okay, thanks, Becca. Right. So welcome everyone. This is Intro to Programming for FTC. My name's Lawton. I've been part of FTC for 4 years now. I'm a junior in Anchorage. I began in 8th grade and now I'm in 11th grade. And so my team is 3208 Hyperlinks based out of Diamond High School. I do mainly programming on my team, but I've also done building and outreach notebook, and I'm kind of like all over the place. So jumping into programming, first we should look at the types of IEDs you can use. So an IED is an integrated development environment. Basically, it's the software you use to code the robot. And in FTC, we have 3 different software you can use. There's Blocks, and I'll get into all these later. Blocks, OnBot Java, and Android Studio. So looking at Blocks, this is I think the easiest of the 3 of them to use. It's drag and drop programming, so it's not actual Java coding. Although the neat thing is as you drag and drop, it generates Java code. So you kind of get like a feel for what it looks like to be working in Java without having to know all the syntax and having all the issues that Java usually has. And then it can kind of teach the concepts of programming, especially for those who have never used it, or if you're coming from like FLL, who's used the Mindstorm program with the same drag and drop interface. It's a good like starting point to move off from. And it's also real easy to get started with. And it integrates well with OnBot Java. So like I said, all the Java code you generate from within blocks can be transferred OnBot Java. And you can modify it there. And then if your team thinks you're adapted enough to use it, you can migrate fully and still have most of the code you program in blocks. It does have a few limits on advanced features. So for example, computer vision. Once you get in more advanced stuff, quite a few teams will switch to Android Studio. And then the other neat thing, potentially neat depending on how your team utilizes it, is that the files are saved onto the Android robot controller, or if your team has one, the control hub, meaning that if you have 2 programmers on the team, both with their own laptops, and set up to share the file, then any one of them who joins the Wi-Fi of the phone or the control hub will have access to all the code. And so that's kind of the same with OnBot Java. It has the same file setup, and they're actually both within the same kind of UI. The big difference between OnBot, though, is that it's Java-based, so you actually get that Java experience that you lack with blocks. And it's got plenty of sample programs. So if you don't want to begin with blocks, you just want to start with Java and move on, there's plenty of resources to help you. Personally, that's what I did. We didn't have blocks at the time that I began programming, so I began actually with Android Studio, but with the same programming language. And once again, it's limited in some advanced features like computer vision. But for most teams starting out, that's not a worry. And then finally, Android Studio. So this is what I think most senior teams will use because of its advanced features. And also the software is meant for like actual Java programming. So a lot of software developers use this in their programming. It can be kind of tedious to set up. That was my big difficulty when I was getting started with it. And it can, unlike the blocks or OnBot, it saves the file to your computer, which can be good if you want to code at home and you don't have the phones with you. Except that you can't code, you can't share code with others unless you integrate with GitHub, which once again is kind of a tedious process and takes some experience to get started. So I can real quick show you how to get set up with each of these. So, give me for a sec. So you'll have to connect to your phone's Wi-Fi, and there's plenty of tutorials I can show you if you don't know how to do that. But then you'd go to the IP address of it, which would be, in my case, and I believe with all cases, this 192.168.49.1:8080. And then when you're connected to the Wi-Fi, this is kind of like a hotspot from the phone. And then you get access to both blocks and on-bot Java. So jumping into blocks first, we can begin by creating a new op mode. And an op mode is just a autonomous or a Teleup. Or if you get more advanced, it can be a file that will assist in one of those. So like what my team does is we have a file that maps movement and autonomous. So say we want to go forward a foot. We have a file that does that. And then our actual drive just, we'll just say like forward 1 foot. And it uses the code from the other file just to kind of simplify and make each file smaller. But so jumping into creating this new op mode, I'm just going to name this simple Teleup. And I'm going to actually use a sample. I can use a basic tank drive. And so this is a file that was created by first that shows kind of like a basic concept or something that can be adapted to most teams starting out. So when I hit OK on that, it'll give me the code of all that that file entailed. So this is just a simple gamepad drive. I don't have a gamepad with me right now, but it would be the left joystick controls the left side of the robot and the right joystick controls the right side. It's the easiest to set up and it's quite intuitive, I find. I've used it for 4 years now. And so, like I said, you can, on the left side, you have all of your kind of code inputs that you can use. If you're familiar with FLL programming, it's mostly the same as that. And then the thing that I find really neat is on the right side, you can see the Java code for all this. So it can be really easy to get started, to drag and drop, and then you can see kind of the syntax of how Java uses these kind of blocks to make a program. And then eventually, hopefully, you can use this as a starting point to build onto Java to get more features and to have more experience once you get into other programming, because industry uses Java over blocks, unfortunately. So that's the basics of blocks. Once again, there's a lot of online tutorials you can use if you want to see more of how to program. And like I said, there's a ton of sample codes, which give you most options. So then still within the same tab, I can just click on on.bot Java. And then this is the Java IDE. So you can see I don't have any projects right now, but I'm the same way as I did in blocks. I can add a file. I'll name this on.bot Teleup. And I can once again choose a sample. I believe the samples are different than the ones in blocks, but it's kind of the same concept. So I can use the have a basic op mode iterative, and then I'll preserve the sample. And what that does is if it's an autonomous, it sets as autonomous. Just another thing to get started with. So I'll hit OK. And this will give me all the code that's saved in this on.bot Teleup sample file that I created. And I believe this file, yep, so it's just a simple tank drive setup, just like we saw with the blocks programming. Actually, sorry, it's not tank drive. It's one stick moves forward and back, one side to side, but it's just about as easy to program. And so, unfortunately, I don't think I'll get into the actual programming this right now. But like I said, once again, there's a ton of samples you can use to kind of get into it. And there's a lot of other videos on YouTube and elsewhere that teach you the concepts. So, this is kind of funny. So now that you've seen, all this was done through the Control Hub phone. So my phone is connecting to my computer. And then this website I'm accessing is actually hosted by the phone. So everything's being sent to the phone. But for teams with the new fancy control hub, there's another way you can do this. So one of the ways is you can actually connect to the control hub's Wi-Fi. I'm actually gonna just a sec. All right, sorry, that's just an external camera I have. But so with the control hub, when you plug in a battery to it and you, actually I'm not gonna get into that just yet, but so when I plug a battery in, then with my computer, I can go in and connect to the control hub's Wi-Fi, which I'm I'm not seeing right now. Oh, there we go. Okay, so I can connect to it. If I knew the passcode, which anyway, but so you'd connect to it the same way you would with a phone. And then the other way that you can connect the control hub, however, is if I use a monitor. And this, I think, is one of the key selling points of the control hub, is that, sorry, 1 second. So one of the coolest features, I think, is on the back of the control hub. You can see there's an HDMI port. And so what that means is if I can plug it into a monitor, then, as you can see in a second, everything that you could do on the phones, you can do on the control hub. And so this includes like starting off modes. You can use it in competition, but you could connect it to a program. And then the super cool feature is, if you can see, I have a wireless mouse with a USB dongle connected and a wired keyboard. And so what that allows me to do is I can actually use the keyboard and mouse. And just like the phones, I can, configure settings, or I can go in and I can actually program from the control hub, which I haven't seen a ton of teams take advantage of this year. So this would be just blocks on Java. You don't have access to Android Studio. But for most teams, this is more than sufficient. So you can see I have I don't know where that came from, but I can create a new op mode just like I did on Java, blocks on my laptop with the phones. I can name it, test 2. And then once again, I can choose a sample if I'd like to. And everything that I could do on my computer, I can now do straight from the control hub, which I think is a super neat feature. Definitely a big selling point. And then same thing with onBot Java. So if I go into onBot, once it loads, then I can once again add any file I'd like and program straight from the robot. So if you could imagine this being attached to a robot, you could use it to kind of code without having any external phone or computer, anything that you need except for monitor. And then one last feature, which probably isn't too productive to programming, but if you would escape enough times, oops, I might have to exit this. If I hit escape, you can actually go, I don't know what software this is, but like you can go on the internet and there's a team who actually went to YouTube and began watching YouTube videos from their robot, which up till now, nobody's been able to do. I think the control hub is definitely a key feature in FTC this year, and I'm hoping it gets adapted more often to other teams.
And Lawton, hey, it's Becca. I just, we had realized that the code we sent out was different, so we've had lots of Zoom issues today. So you do have Andy Miller from Skagway is on listening now. And so Andy, except he just popped off, but he should pop back on. He might have questions, and hopefully we'll get a couple other people. But like I said before, we are going to post the recording of this because I have a feeling people are really interested in it. Is it okay with you if I put your contact information on there for people to follow up with too?
Yeah, that's fine.
Okay, great. And there's Andy, if you want to just say hi. Is your audio working?
Hi, Andrew. All right.
Okay.
So moving on. Also, for teams who did want to use Android Studio, like I said, it's kind of a tedious process to set up. So I wasn't going to go over it in this video, but I linked to an awesome website that you can use. This is the official first Android Studio tutorial. It uses the same programming language as OnBot Java, so anything you make in OnBot Java can be transferred to Android Studio. It's just uploading the code, and the user interface is a little different. So just a few tips that I've gathered through my 4 years in FTC. One is to invest in a dongle, which looks like, oh, I can't actually disconnect it because my Wi-Fi is connected right now. But it's just a tiny little, actually looks just like this. So I don't know what happened to my screen. Oops. Okay, so it looks just like this. And then it'll plug into your computer. And the awesome thing with this is it allows you to connect to a second Wi-Fi. And that means that if you ever wanted to have your programming and then you don't know how to do some programming thing and you want to look it up, usually what you need to do is disconnect from the phone / control hub and then connect to a different Wi-Fi, look up what you need to look up, and then move back and connect back into the phone or control hub. But what this allows you to do is create a second Wi-Fi, and then you can have one connected to the phone and one connected to the internet. So you can go on Wi-Fi and look up what you need to look up to know how to program something, and then copy and paste it or do whatever you need to do to get it on the phone without having a disconnect. And this is especially useful for Android Studio because unlike OnBot Java or blocks, when you want to connect to it, you actually have to plug the phone into your computer and then run this code that essentially creates a wireless connection. But that, so that takes up a ton of time. And every time you want to switch from programming to looking something up, you'd have to unplug the phone, plug it into your computer, connect, and then unplug it and plug it back into the robot. So I think if you're going to use Android Studio, it's like almost essential. I actually just discovered it, but I couldn't see myself coming out of this season without it. A second tip is to use encoders. So if you are familiar with the NevRest motors, or I think the Rev motors have them, and Activotics motors, and just about every motor used now in FTC has 2 slots. One is for the power, so you have the 12 volts going in, but then the other one is for an encoder, which basically gives you the position of the motor at any time. And so what this allows you to do in code is without an encoder, like I did my first season of FTC, we would have the motor drive by time. So we'd say the robot would move forward for 1 second, turn for 2 seconds, move forward for like 5 seconds. But the issue with this is that if your battery is at, say, like 14 volts, then it's going to be moving at, some speed. But if it goes down to, say, 12 volts, it's going to move considerably slower. And that means in the 2 seconds that it's moving, it's not going to cover the same distance. And then your autonomous becomes unreliable. So when I was starting out in FTC and we had this issue, we decided to solve it by keeping our battery between like 12.5 and 12.4 volts, which was a huge hassle. And then whenever we'd see the autonomous mess up, we'd be like, oh, we didn't charge the battery. We used too much of it waiting. And it was unreliable and we had a lot of issues. So what an encoder allows you to do instead is it gives you the feedback of the motor. So if you, instead of saying go 2 seconds, you can say go 5 rotations of the wheel. And then no matter what charge your battery's at, it's going to move for 5 rotations. And so that makes your autonomous for more consistent. And it's also almost as easy to program as with batteries because of all the examples that that Frisk gives you and you can find online. Another tip is to take advantage of telemetry. So if you notice this is the driver station phone, at the bottom you have this little console output. Right now just a status, your robot is stopped. But you can actually use in programming this feature called telemetry to output data. So one example that I use this for is when we were using encoders. One season, we had this one wheel that just wouldn't spin. It would spin and spin and spin. It wouldn't stop when the other ones do. And so we wanted to see like, what's this or this? So we output the position of the motors to the telemetry. And then we could see that when the other three wheels spun, this one didn't pick up any spinning motion. And I believe then we forgot to plug in the encoder. So it can be useful for stuff like that. The other thing it can be useful for is if you are in, say, a competition or you're programming a Teleup for one, sometimes there's data that you want to send to the driver that you couldn't usually receive, like this season, the past season. My team had this slow mode, so it would basically have the robot drive at half speed, but we'd always be kind of confused when it's activated. So what I had it do is it would print just to this bottom. It would say slow mode, enabled or disabled. And then whenever we swapped the slow mode on or off, it changed. So we could get a quick reading and we'd know like within the competition when it's enabled and when it's disabled. And it's just like a little more efficient, but it can make it go a long way in some matches. The next one is to back up your code, which I'm bad at doing myself. I've had a few times when that's caused issues during competitions. And actually, I think I'll show you how to back it up because it's super important that you do it. So going into onbot Java once again, the way you do it with this is once you have a program, it's really easy. You just right click and hit download. And then in your downloads folder, it pops up. And then what you'd want to do is you'd want to save it somewhere offline. So I've heard a lot of teams save it at thumb drive and then take the thumb drive to competitions. You can also save it at cloud, like the iCloud or Dropbox. And so I think usually the best practice is to back it up before every programming session. So if sometime you have some like major issue and everything fails, you have a backup you can go to. The same thing can be done in Android Studio. And what's really neat about this is that since the file is saved to your laptop and not to a phone, you can have this do it somewhat automatically. So the way I have it set up right now is in FTC, I believe. No, sorry, it's not an FTC, but it's I have a folder in my iCloud that saves the file. So it's not actually on my computer, it's on the cloud. And if I were to be at school one day and I don't have my laptop, I can go to iCloud and I can access all the files. And then if I wanted to make a backup, I do kind of the same thing. So say I wanted to save Gyro Auto, I can right click it and say reveal in Finder. And then you can see this is all the team code I have. So I can copy this and then what I want to do is create a folder somewhere and I could name it programming backup. And then you just want to paste it in. And once again, you'd want to do this every programming session. So if you mess up one of them, then you have a bunch of backups you can go to. Or if you ever have a time when just something isn't working and you know back 2 weeks ago you had the same program, just a lot simpler, you can go back to it and you can see if that's working. And then you can know if within that time you messed up a programming, something programming wise, or if your hardware is having issues. So next would be use logical naming conventions. I think most teams, it's kind of self-explanatory, but there's some teams who don't do it. So for example, my team last year we had two motors that would drive the robot, and we named them left drive and right drive. But just make sure that you're not naming it something odd like motor one, because that can cause tremendous amount of confusion when you want to actually program. Even just naming it like left drive, you get confused because you forget, like, is the robot facing forward and it's left, or is it facing backwards and it's left? But just something that can be easily remembered and you can repeat enough times that it kind of gets ingrained in your memory. And then one thing that I think a lot of teams neglect is that when you're configuring, so in Java, I actually give some back story on this. You have to create a variable name for every motor you use. And thus I'd say like left drive refers to the power that the motor is being given that drives the left wheel. But then you also have to pair that with what the phone thinks the left drive is. So when you plug a motor into port 1 on the control hub, you need to tell it that port 1 is left drive. And I think a lot of teams, they don't realize that you can name them the same thing. So they'll name it like motor port 1, and then say motor port 1 in the phone is the same as left drive in the computer. But this causes confusion once again if you were to get confused in with which motor is plugged into which port. And so there's nothing wrong with naming the phone, what the phone knows is it's plugged into the control hub, the same as what you call it in Java. And so once again, just an easy way to reduce confusion. And then finally, keep a simple Teleup on hand. So I know a lot of teams, my own included, we like to make really complex Teleups. So we could have one that had like some fancy driver controller, has like LED lights, just some really fancy stuff. But the issue is if you program something from that, and then you suddenly see, oh, one of the motors isn't spinning, it can be tough to tell if it's something that you programmed incorrectly or if it's a hardware issue within the bot. So what my team does is we have a Teleup that's just a basic tank drive. It's like, 20 lines of code. All it does is say the input from the joystick is going to output into the motor. And then this way we can tell if we have an issue with one of the motors like not spinning, then we can go into this simple Teleup and we can know, is it a hardware issue or is it a software issue? And this actually proved really useful my second year doing FTC, because we noticed after we did a bunch of programming stuff that when we drove, the bot would swerve to the left. And we had no idea if the motor was bad or if I just programmed it to like divided the left side by 2, so it would go at half power. But using this simple Teleup, we enabled it and then we saw it still turn sideways, so we could eliminate a software issue as being the cause. And then I think we found that the chain was too tensioned and so it's causing friction. That's most of what I have. So like I said, I don't think there's enough time to actually teach programming. And since everyone's at a different level, it's tough to get everyone included into one programming session. But there's a ton of resources you can use to begin programming. If you want to use Android Studio, you'll have to download the project off GitHub. So this is the Android Studio, or the FTC SDK, which is the software developer kit. And basically what that means is it's the files that the phone uses to communicate with the control hub and with all the software that's included. And so you don't have to download this if you're using onbot Java or blocks, because it's already included in that software. But if you're using Android Studio, you'll want to make a download of this and then upload it to Android Studio. So then also FTC first has released a bunch of programming resources that are helpful. So if you go to the Programming Resources tab, then you can find for blocks and onbot Java and Android Studio, they have training manuals for each, along with I think sample projects, and just basically everything you need to get started. And then everything that isn't included, I think, you can use the sample code within the Java and kind of build off that, as well as just general Java programming videos that you can find online. Because no matter if you're doing Java for FTC or if you're doing it for building an Android app, it's the same Java, it's just slightly different, some slightly different things, but it's all the same programming language. And everything that FTC has created is within the same kind of syntax and Java language. So you can use any resource basically that's Java to help you with your programming. And so, like I said, they have that for Java, they have that for Android Studio, and they have it for blocks. Anyway. And then, like I was saying with the dongle, which allows you to connect to a phone, along with a Wi-Fi that can connect the internet. This is the link that I use to connect it. It can be a little confusing, but I think this does a good job at explaining how it works and how you get it started, and also how to integrate it with Android Studio, which is another big issue, is that usually by default with Android Studio, you have to plug the phone into your computer every time you want to upload code. But that's totally tiresome and tedious, and you'd eventually probably break the port on the phone from having to unplug and plug it in so many times. So definitely, if you choose Android Studio, make sure you use this this wireless communication, so that you don't have to switch the phone each time. I did that the first year I was programming, and it was awful. I think probably 75% of my time was spent moving the phone and turning the robot off and back on, and trying to connect everything. And so then if you do run into issues, there's a few places you can go. The FTC Forums is the best one. This isn't just for programming either. So if you have a question on if some gripping mechanism you want is legal, you can ask it in this, or programming specific. They have this technology tab, and then you can create a post asking whatever your question is, even if it's something like connection issues or a software bug that you found. All of it can be asked within this technology forum. And finally, if you have just a general Java issue, like you have an error when you upload your code, like if you got a semicolon, you don't know how to use the brackets, this has an awesome database. So you can look up, bracket Java. And then chances are someone's had an issue with the same question you have. And then you can look through and see who's answered it. And if you have a question that isn't solved, you can ask a question. And then after you sign in, you can create your own form, and there'll be a ton of people who are willing to help you out. And then one last piece I should mention is if you are in state and you want some help, just about every team you ask who's had experience with Java programming in the past would be happy to help you. I know I love this stuff personally, and you can contact me with any issues. I believe my contact information will be in the bottom of this video. But just any team who's had and has experience with programming, I'm sure they'd be happy to help you. My first year doing this, we had a lot of help from a few other Anchorage teams. Just like during competition, we'd be programming, they'd walk by and they'd see that I'm struggling. They'd help, and if you ask them, sure, they'd be happy to. That's all I have for my presentation. Is there any questions in the audience? If not, no questions. All right. Hey, Becca, are you there?
Are you going to show your contact info?
Yeah, you can, I don't have a slide for it. I believe if you look at this video afterwards, it'll have my contact info, but my email, if you ever want to contact me, is lscaling@icloud.com. I'd be happy to answer any questions you have.
Awesome. Thank you.
Yeah. How's your team coming with programming so far?
We're a rookie team, and we got a late start, and it's going very poorly so far. So
Oh, really?
We just threw together a chassis and put some wheels on it, some motors, and we're trying to throw some code in there to see if we're doing it right. And so far, we can't get it going. But yeah, we're just getting started.
Yeah, it can be tough when you start out. I know my team, my instructor had a previous year of experience, so I was able to get some help. But a lot of it is just on your own. Like it can be tiresome at the beginning, but you get used to it, and then you have a building block that you can start and build up from, and then eventually you can get into some pretty fun programming stuff. But I can understand when you have issues at the beginning. There's not a lot you can do to help that.
Yeah, that's where we're at now. But yeah, we may reach out to you if that's okay, and just kind of show you what's happening and see if you can't see what we're missing.
Yeah, I'd love to.
Awesome. That'd be great.
Well, with that, if there's no other questions, I guess I'll end the stream now.
All right.
Thanks for tuning in.